Okay, let's do these two. So looks like I'm unprepared for class. I definitely want to calculate. Okay. All right, now number 12 has a detail in it. Did anybody see the detail? Yes, it's got a negative e in it, so we're gonna have to be careful with that. So minus 5.6 negative e to the 6a equals negative 43.6. Okay, and then just divide both sides by -1. Just pretend that negative is a -1 in front, which it really is. We just didn't write the one because we're lazy. Did you figure that out on your own without me? Probably. Okay, now I'm going to bring the 6a in front and then natural log both sides. ln and e cancel. Only on this side, not both of them. Just thinking back to your quiz grading. Natural log 43.6 divided by 6 is 0.6292. Any questions about number 12? We good? Okay, 14. First, decide the operation. It's plus, that means it's times. So natural log 2 times 5x minus 7 equals natural log 21. And this is a cross out type problem. So cross out the logs. 2 times 5x minus 7 equals 21. 2 times 5 is 10. 10x minus 14 equals 21. Plus 14. Done. Any questions about that? Okay, I don't think you need your packet anymore today. So you guys can put the packets away. Any dot paper left in your packet is for your homework problems or whatever else you need it for. I don't think we have any more in the classwork. Okay, so you guys remember that homework problem where you had to draw the planes and find where they cross or the different situations where they cross? Remember that? It was super fun. You like drawing them? I'm sure you did. It was like AP art for you. Just kidding. You might not have liked it. I don't know. Today we're going to do the algebra part of finding where they cross. And this is, I gotta be honest with you, and this is one of those lessons. It's not hard. Like the math's not hard, but it's one of those where you miss a negative in there somewhere and it messes up your entire problem. This is one of those where you miss a detail or you write something down wrong or you're the tiniest bit messy and the whole thing is just like, So warning you ahead of time, write neatly and carefully while you're doing this type of problem. We're gonna do 4 problems. One of them is a math 1 review. This one is gonna be just as most, it's nothing for you to write really. We're just gonna look at the screen. 78 is gonna be notes, and then 79 is gonna be more examples. Homework is 82 to 88, skip 87, and this is pi, and he's on the phone, and it says, to continue in degrees, press 1. To continue in radians, press 2. To continue in grads is gradients, which is something that you won't learn until college, press 3. You get it? You get it? Like, to continue in English, press 1. He didn't like it. I knew he wasn't gonna like it. I thought, what? You don't get it? Like, degrees, like radians, conversion, degrees to radians, degrees. Yeah. It's like the language that you, and it's pi. So anyway. Okay. Let's start with all right, guys. So I'm gonna talk about this a little bit while you're finishing this up. So 75 is a Math 1 problem. It's got 2 lines. Can you tell that those are lines? And you probably, because of Wednesday, could graph them with the cover-up method and then find where they cross. We're not going to do that. But the question in this problem is to solve the system. Solving a system means that you know that those are lines and you're attempting to find their point of intersection. So you're finding where they cross. We're going to do it algebraically, not graphically. There are 3 ways to solve a system. The first way is called equal values method. Equal values method is used when both equations are equal to y, and then you equal them to each other. Does that make sense? Do you remember equal values? It was everyone's favorite at the time. The second was called substitution method, and that was when one of them was solved for y, but the other one wasn't. And you took the stuff that was solved for y and you plugged it into the other one. Remember doing that? Okay. And the third one is this. This is called elimination method. Elimination method is what we're going to do with almost all of our systems in 3 variables. So what you do is you look for a variable to eliminate. This particular problem is kind of dumb because it's the easiest type possible. Do you guys see that the y's cancel? You have a negative 2y and a positive 2y. So all you have to do is add the 2 equations together to eliminate the y's. This is almost too easy of a problem for a review problem, but that's okay. It's what the book offered us. So we're going to add these two together. And I'm going to put an arrow here because technically you're supposed to look at the problem and say which variable is easier to eliminate. In this case, the decision is so tiny. Clearly, that's the best one to eliminate because those cancel immediately. But we're going to have to put some thought into when we actually do our problems. So anyway, 12x plus 30x is 42x equals the y's eliminate. And what's 16 plus 68? 84, that would make sense. Okay, this is not the end of this problem. We found x, and we need to plug it back into one of the equations to get y. It doesn't matter which equation, just pick the one with the easier numbers. I'm going to pick the second equation because it's all positive. So 30 times 2. So I took the 2 and put it in for x here. Okay, so two comma 4 is the point of intersection between these two lines. Back in math 1, you did this so many times that you probably wrote POI for point of intersection after a while. Does anybody remember the two types of like strange answers you could get, the two unusual cases you could get with a problem like this? So sometimes you get an answer for a point of intersection. Does anybody remember either of the two unusual cases? Okay, no solution. No solution happens if the lines are parallel and they never cross. There's a bunch of memes about that, how it's sad that two parallel lines will never meet. Anyway, that's no solution. Anybody remember the other option? Yeah. Infinite solutions is when they're on top of each other. So same line. Those are your three options. It's either point of intersection, no solution when they're parallel, or infinite solutions when they're the same line. There's a lot more options when there's planes. You guys drew some of them in your homework last night. Okay, now for 76, what I did was I typed this problem for 78 into Desmos. And I actually typed a lot of things into Desmos, but I'm just going to show you this particular system of three planes. So all you're going to do in this problem is look at Desmos, which is great. Okay. I'm going to rotate. So I only have the three from this particular problem on. I could turn all of them on and it looks really cool. But for now, we're just looking at these three. You have three planes and your job right now is to visualize where all three planes cross each other. Maybe Mr. Kepin can find it. Mr. Kepin, can you find where all three planes cross each other? I think it's right here. Did you know Desmos has a 3D option? And did you know that it can do this? Look at it, look at it, look at it. Okay. Do you guys see that the red and green and blue planes cross at this point right here? Can you tell? Okay. Now the question is, what is that coordinate? I'm going to turn, okay, wait, hold on. I'm going to turn the Desmos so that it looks like our graph paper. So I have X and on the left, Y on the right, V on the top. Can you tell it all what that coordinate is? This coordinate where all three planes cross. You can't, it's okay, you can't. That brings the need for us to do algebra. You're like, oh, good. No, good. It's not hard. It's just that it's very mistake prone. So we just have to be super careful. What we're going to do is the notes. We're going to actually solve this. And then at the end of 78, we're going to come back and see if we can figure out why our answer makes sense. So here's our answer right there. But now we have to do algebra to go back and say, okay, why does that answer make sense? Okay, notice the amount of room that I've left for this problem. And I'm also going to use two colors. I'm going to use red. So if you have access to another color, I would highly suggest you get that out. Okay. Whenever you have a problem like this, the first thing you want to do is look at the X's, look at the Y's, and look at the Z's, and make a decision about which one of those is easiest to eliminate. This problem is easy. This is an easy style problem. This is like level 1, easy. The next one we're going to do after this is not as easy. But do you see which one makes the most sense to eliminate? Does anyone feel comfortable enough to make a guess, make an educated guess about whether X, Y, or Z is the best option? Why? Why is the best option? Why is Y the best option? Because the coefficients are all 3s. They're all the same number. Some of them are positive, some of them are negative, which actually helps us out. Okay, what I want you to do is number your 3 equations and put that arrow above the Y's. Okay, the first step is I'm going to separate these into 2 problems like the math 1 problem. Does it make sense to you that I'm going to put equation 1 with equation 2, and then I'm going to put equation 1 with equation 3? Do you see why that makes sense? Does anyone see why that makes sense? Nobody. Nobody in the whole classroom sees why I might want to put 1 and 2 together and why I might want to put 1 and 3 together. Yes. Okay. Because that gives me 1 positive and 1 negative in each set. So I'm going to put 1 and 2 together. And I'm going to put 1 and 3 together. Okay. Are you realizing at this moment what the utmost priority is here? To be extremely neat with writing the problem down and extremely neat with your work. I'm hoping that you see how imperative that is here, because one little mistake of writing it down wrong. Yeah. Okay. So we're going to do the same thing we did above. So we're going to add these 2 together. And the whole point of it was to have those be opposites so that they will cancel. So this gives me 4x plus 8z equals 12. And this gives me x plus 6z equals 11. Okay, so pausing here. This is something we can't go too fast on. First thing we did was decide the y's were the best things to eliminate. Then we noticed if I put these two together, I'd have a positive and a negative. And if I put these two together, I would have a positive and a negative. So I grouped 1 and 2, and I grouped 1 and 3, and eliminated the y's from both. Then I took my answers and lined them back up to make a Math 1 style elimination method problem. So now we have a problem like this one. Okay. Which variable is easier to eliminate, x or z? X, right? Okay, and how can I change x so that I can cancel it out with 4x? So you want to multiply the whole bottom equation by -4. You might be remembering this now from Math 1. It might be coming back to you. 4x plus 8z equals 12. -4x minus 24z equals -44. One mistake students make is they don't multiply everything and then get stuck in there somewhere. Now the x's eliminate. That was the whole point. Okay, now math problems typically don't give me anxiety, but this, if I was going to get anxiety in a math problem, it would be right here in anticipation that that would come out to a whole number. So that would be your first indication that you did something right or wrong right there. Are they always whole numbers, Mrs. Talbot? Absolutely not. But most of the time they are. Okay. Now, I have Z. Am I done? No. Okay. What I'm going to do next is I'm going to take this Z and I'm going to plug it into either one of these two. I usually do this one just because it's over here. Okay, we have one more step. We have Z, we have X. We still need to find Y. In order to do that, we have to plug back into one of the originals. Original do you like best? 1, 2, or 3? It doesn't really matter, does it? Let's just do 1, just so. Okay, now because this is notes, I'm going to put a 1 here and I'm going to write the problem again. Hey. Okay, perfect. I'll send them. Did you get my message? It was just to see if you wanted to look at the AP stats numbers together. Yeah, just whenever you want me, just call me and I can. Okay, okay. Bye. Bye. Sorry, it's Miss Cole. Suraj, Miss Cole wants to talk to you. Okay, so I'm gonna write the problem down. Negative 2x plus 3y plus 4z equals 1. Okay, negative 2x is negative 1 plus 3y plus 4 times 2 equals 1. 2 plus 3y plus 8 equals 1. Okay, so final answer for these should be a coordinate. It should go in alphabetical order. -1, -3, 2. Sometimes they're not X, Y's, and Z's, by the way. Just make sure your coordinate is in alphabetical order. Okay, now the answer is -1, -3, 2. What we're going to do next is go back to Desmos and see if we can figure out the answer -1, -3, 2, and if it makes sense. Okay, so first I'm going to look at the x-axis, which is right here. Here's the point. So it's saying you go back 1, back 3, and then up 2. Does it look like it might be possible? Back 1, back 3, up 2. I would never get that from this picture. And unfortunately, the 3D Desmos doesn't have the thing where you can just click and it'll tell you. There's no clicking and giving you the answer. It's just that. Also, the 3D Desmos doesn't make a table either. There's no option for a table. So, cripes, we actually have to do the algebra. Okay. All right. I picked C to do next because I wasn't sure how much time we would have. This one is spicier than the other ones because I felt like we should have an actual spicy one. It's not horrible. It's not great. And then if we have time after this, I want to show you a weird one, which will take us only a couple seconds. Okay. First question, discuss it in your groups for 10 seconds. Make a decision. Which variable is best to eliminate in this problem, X, Y, or Z? There's a clear answer to me, but you guys might disagree. X, Y, or Z? The answer is Z. Okay, Why is the answer Z? Because 2 goes into 6, but 4 does not go into 6. But 1 goes into 6 and 1 goes into 5. So what I mean by this is I can take this one with a plain Z, multiply it by 6 to clear out the Z's in that one, and multiply it by 5 to clear out the Z's in that one. So what I'm telling you is it's best to choose one with a plain letter in it if you can. So I'm going to do equation 1 and 2 together. Guess what, though? If you chose Y's and still did elimination method, you might get the correct answer. I'm just trying to save you, like, work. But to be honest, you can choose any of them that you like better. I'm going to do 1 and 2 together, and I'm going to do 2 and 3 together because I want that plain Z with the other 2. Okay. All right, so I wrote equation 1 and 2. I wrote equation 2 and 3. Hopefully I wrote them down correctly. We will see. On equation 2 over here, I'm going to multiply the entire thing by 6. Why did I choose 6? Because I want a negative 6z and a positive 6z to eliminate. No. See, already screwed it up. Already screwed it up. Hold on. This time I have to multiply the top one. Okay. I want to multiply the top one by 5 so that I have a 5z and a negative 5z. Okay. Z's, Z's. Anyone see any flaws in my math? Anything? No? Not yet? Okay. Now, which variable is best to eliminate here? Yeah, the x probably. I would just multiply the bottom one by -1 so that you have a negative and a positive to eliminate. Is that what you thought to do? You could also multiply the bottom by -2 to eliminate the y's. Same amount of work, really. Okay, not a whole number, but not a horrible number. Okay, we got back to whole number. That makes me feel a little better about things. Is there an equation on the top in the original that's better than the other two? And the second one, maybe? Okay. Negative 2x plus 2y plus z equals 5. X, y, z. Last problem. This is going to be quick. Can you guys tell just from looking at it that it's weird already? What? Okay, that excellent point. So it says there's no y in it, which freaks out a lot of students, but really, to be honest, it just means that somebody already did a bunch of work for you. If one of the equations is missing a letter, you should probably try to eliminate that letter in the other equations. That means that someone already did some elimination for you. If you don't like that, you can just add a plus 0y into the equation. If you add plus 0y, then it will look like the other ones. Okay, but what I want to say is, do you guys notice that what? Yeah, hold on that thought. We have two separate issues going on here. We have the fact that these two are strikingly similar, and we have the fact that this one's missing a y. But I want to start about the missing the y first. If one of your equations is missing a letter, eliminate that letter in the other two, because somebody already eliminated y in this one. That's good. That means that you have less work. Okay, so over here, I realize that these two are so similar that you're going to feel weird about this, but we're just going through the motions. Okay, I'm going to multiply this bottom equation by -1 because I want a positive 12y and a negative 12y. Negative, 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 negative. This is supposed to be weird. Remember, I told you it's weird. So there's two things weird about it. Y was already eliminated in the bottom one, which isn't a bad thing. That just means less work. But also the top two are strikingly similar. So the x's eliminate, the y's eliminate, the z's eliminate. That means you have 0 on the left side and then -60 on the right side. So this is no solution. And you have parallel planes. Can you tell which two planes are parallel? The first two, because all their stuff is the same. that problem was actually done, but I am not done. I want to show you Desmos for for both of these two problems. Remember that it's possible to get infinite solutions. Also, what would the math look like here if it was infinite solutions? Yeah, either -60 equals -60 or 0 equals 0. And then you would have infinite solutions with the same plane, the same exact plane. But take a look up here real quick. Okay, so I'm going to turn the original problem off. Here's the problem that we did for number 79C. The point of intersection looks like it's right there. What was it? -1, -1, 1/2, 2. Okay, so hard to see, but you can tell that they cross in a coordinate. Unlike these, do you see, this is what I really wanted to show you. Do you see the parallel planes? That's why this one is no solution, because they don't all cross in a single coordinate. They cross in two lines, which is like here and here. But it looks cool. Okay, now, most fun part. Ah, crazy town. Spin that. Somebody should 3D print that. Please don't, please don't, please don't do it. That'd be a lot. You know how to do that? Yeah. Okay, you guys, that's it. So, moral of the story on all of these problems, write carefully, go slow, be careful.